Welcome to Programming in Modern C++. We are in week 3 and going to discuss module 15. In the last module, we have introduced very critical concepts of copying as a construction when the object does not exist, and copying as an assignment when the object exists and being overwritten. And in this context, we have mentioned or discussed about deep and shallow copy issues, which are very critical. In this module, we will look at the effect of constness in the design of the user defined types. We have seen constness in the context of built-in types. What does const mean? What can you do? What is a constant pointer and all that? We will see the consequence of all that in terms of the objects, data members and its member functions. That is the basic objective. So, a constant object is an object which cannot be changed, right? Like user defined types, any object can be made constant, and an object is constant simply means that its state cannot change. Nothing can change in that object in terms of the data members. So, when you do that, what happens in the this pointer, type of the this pointer in the for that particular object changes. So, earlier the this pointer was just a constant pointer, because you cannot change the identity. But now you have a const in front of this, which say that the object pointed to cannot be changed. So, nothing can be changed in that object. That is the simple extended idea of constant object based on the. So, here is a non-constant object. So, I have a private member, I have a public member. Please note that here I have not written private. If at the beginning I do not write anything, then it means private always, and then I have written. So, I have a private and public member, and I have provided get member and set member on my private member, because public I do not need to do, I can directly access that. So, I can make all sorts of changes, I can read both of them, set both of them, print and all that. This is the usual non-constant scenario. What happens if I make things constant? So, all that I have changed is in my object creation declaration time I have made it a constant, like const int I do, I made const my class. So, it says that if it is constant, then what is the change that is going to happen? The change will be that this pointer of my const obj is now const my class right, because it is a constant object. So, it is this pointer has changed with this const, whereas these functions, member functions that you have written, whether it is a get member or a set member or print, all of these expect a this pointer which does not point to a constant object. So, even you would say that why is get member not working? Because get member is not actually changing it, get member is just getting the value, but the compiler will not make it work, because get member here expects a this pointer of the type which is constant by itself, but does not point to a constant object, whereas what it gets is including this const. So, there is a type mismatch and it will not allow that call to happen. So, with that you can see that this will not work. Obviously, similarly print will not work, set member will not work, none of these will work. This will also not work. this is, there is no function call, this is just a assignment, this will not work because that is your basic statement. So, you cannot make an assignment to that. So, that is the simple interpretation of the const object. So, the key point to note here is you cannot change anything, that is fine, but the key point is even if you want to invoke a function which does not change anything, you are not being allowed to do that because the compiler cannot distinguish. Right? So, we move on to handle this situation that in a constant object, I should be able to invoke member functions which does not change the object, because the constant object, the state cannot be changed. So, if I have a member function which does not change the state of the object, it should be okay to call that. If there is one which can potentially change the state of the object, that must be guarded, that must be, because otherwise the constantness will disappear. So, C++ introduces what is known as constant member function. What it simply does is it puts the keyword const after the prototype header and before the body, between these two, the header and the body, it writes const. What change does it bring into the compiler? It tells the compiler that pass a const my class star const this pointer as a this pointer to this function. Right? So, now the match will happen 1. The second it tells the compiler is that this function is a constant function, constant member function. So, do not allow any change to happen to the state of the object within the body of this function. Right? So, if we look at two functions, there is print which just accesses the member reading the value, and there is set member which I have also defined as const, where I am trying to set a value. Now, this will be fine, but this will be a compilation error, because in a constant function you cannot change the state of the object. Right? So, now you have the full story covered. Constant object does not change states. Member functions, anything that I want to use without doing a change, I can define them as constant, and anything that changes the object cannot be invoked on this particular constant object. Right? So, if I define a function to be constant, then try to do something within that to change the state, it will not be allowed in the compilation. Right? So, that is the basic idea. So, now let us look at this. So, I again have two members, public and private, the constructor. The get member I define as const. That is, even if the object is constant, I must be able to get that, there is no problem. The set member is done as non-const, that is, it will take my class star const this only, because it wants to change the data member. It clearly tells the compiler this function will change the state, this function will not change the state. Similarly, print I make const because I only want to read the public and private members and print them, I do not want to change anything. Now, let us define two objects, one is my obj and one is my const obj. This is non-constant, the second object is constant. Now, if the object is non-constant, then I should be able to invoke any member function. If the object is non-constant, I should be able to invoke anything, it does not matter. So, I can invoke the non-constant member function. I can also invoke the constant member function, because the constant member function says that I am assuming that the object cannot be changed. So, if I give it an object which is okay to be changed and that function does not change anything, I am not violating anything. Right? That is, in other words, any pointer like x star const this and const x star const this, where x is the name of the class. Any pointer which is non-const pointing, any pointer which is pointing to a non-constant object can always be treated as if pointing to a constant object. There is no violation. So, this is what, as we will see, is a valid pointer cast. Whereas, if I try to do this, then it is a violation. If it is, this is saying that this pointer is pointing to an object which is constant, I cannot change that to a pointer which is pointing to a non-constant object. So, for that, so the consequence as you will see is that on the non-constant object I can do anything. Of course, I can do direct assignment also. But for the constant object, I can do this, which is a constant function get member. I can do this, which is a constant function, because they guarantee that they will not make change, but I cannot invoke this. If I invoke this, I am trying to change this pointer pointing to a constant object to this pointer which is pointing to a non-constant object, which is a violation. Right? So, if I try to do this, the compiler will not allow me, it will give me a compilation error, and obviously I cannot do the assignment. So, by combining the constness of the data member and the constness of the object and the constness of the member function, we can easily invoke any member function. Now, let us see what happens with the data members. Now, if I make an object constant, then the entire of the object is constant, but oftentimes I have designs of classes where only a part is constant. For example, several examples can be constructed. Here is an employee. Employee's ID is not expected to change. Right? Employee's date of birth certainly cannot change. So, once you have created, they are fixed. Whereas, the employee's designation, employee's address, salary, this could change. For a student, the roll number and date of birth will not change, but certainly address, GPA, year of study will keep on changing. For a credit card, maybe the credit card number and name of the holder should not change, but others can change. Okay? So, it is not enough to be able to just define an entire object as constant. I want to make just specific data members to be non-changeable as well, and it is just an extension of the idea of constness which let me do that. So, now I have 4 data members created, 4 data members in this design for understanding. So, there is a data member C prime m, which is a private constant data member, which means that I should not be able to change it ever, whether the object is constant or the object is not constant. And then I have a normal private member. Similarly, I have a public constant data member, I have a public normal member. I have a get and set on the constant member. Now, the get obviously will work because I can read, but the set is trying to change this. Mind you, the object is not constant, the object is non-constant, object is non-constant, but I have told that this particular data member must be constant. Therefore, making any change to that is not allowed, and the compiler will give you a data assignment error. Whereas, if you want to try the other one, this one, which is a non-constant data member, then you will be able to read it as well as write it. Right? So, if you try this out, then you will see that there is a problem with the set C prime member function, which cannot be compiled because of the constness. Similarly, here you cannot make a direct change to this data member, even though the object actually is non-constant. So, using this, you can you did a practice, I hope, of the credit card and related classes earlier. So, now you can introduce the constness in this very nicely and make a design which can keep all these promises of what values should change and what values should not change. I am sorry. So, this is a string class which is just for support. This is a date class that you have seen. What I have added? We have added const here. That is, it is at even if the date is constant like in date of birth, I should be able to print it, I should be able to validate it, and I should be able to say which day is it, right. So, these are and we have also included the copy constructor and copy assignment operator to be able to work perfectly. There is the name class. In the name class, we have the print made into a constant member function, so that I can print anything that I want. Additionally, we have put the copy functions, right. We are just trying to show you how slowly the design builds up. Then I have the address class. In the address class, again the print is a const function, copy and assignment operators are added, right. I am just flipping through. You have to really study this code, understand how to write them again and try it out on your compiler and see what you are getting. So, finally, the credit card class. So, credit card class has again the same type of changes. Print is made const, you have the total credit card constructor, and you will be able to with this construct any credit card information, right. So, you have credit card constructor here, you have the credit card destructor here, and you have after construction you have all different functions given to be able to change the respective values, like the name of the holder, address of the holder, issue date, expiry date, CVV number, and so on and so forth. Okay. That is our initial design. Now, I write an application with that. So, this is the object I am constructing, the card name, the holder's name Sherlock Holmes, the holder's address 221B Baker Street in London, and so on, and the date of issue and all those. I mean, these are all obviously meaningless data, and I can change that to the name of say Mr. David Cameron residing in 10 Downing Street, change the date and all that. I can make all these changes and you can see the effect, right. So, you can see that the design I have provided does everything, but it makes the class vulnerable, because I was able to change even the name of the holder. I have not changed the credit card number, but the name of the holder has been changed from Sherlock Holmes to David Cameron. This obviously is not acceptable, right. It has to be stopped, right. It should not be possible to do this. So, now I introduce the constness here. So, what I do? I make name a constant data member. That is, you can once you have created, you cannot change that anymore. Once I do this, then this set holder function will no more compile, because I am assigning to that, right. So, I have to get rid of this function, because if the name is constant, there is no need for a set holder. So, this cleaner one, I have moved the set holder function, done, clean code. Now, so now I have the revised application. In the revised application, what I am doing is I have removed the set holder function. So, keeping the card number same and just changing the name to Mr. David Cameron is not possible. So, that part of the code I have commented out, right. But it is still possible to edit or replace the card number, which should also be disallowed. Right? So, how do I put that constraint? So, I say this is the card number issue. So, what is the card number? Card number is a string, which is dynamically allocated and initialized with value at the time of construction. Right? Now, to make, I want two constraints. One is I want to make the card number non-replaceable. That is, I should not be able to change that card number and put a different card number. What does that mean? This is a pointer. So, I need it to be a constant pointer, because then I will not be able to change that card number to something else. You have already understood that. The other is I also need the card number to be non-editable. I should not be able to change few digits in that, which means that the card number pointer, the string that it is pointing to, that should also be a constant. It should be a constant string. So, requirements of having the card number non-editable and non-replaceable is to convert this pointer into a constant pointer to a constant char star. So, now I have done that, I have made it into a constant pointer to a constant char star. So, it cannot be changed after the construction. The name of the holder also is constant. So, that cannot be changed. So, with this now we will have some problem, because when we were doing this allocation in the constructor, this is what we wrote. Okay. That is, at that time it was not, card number was not no constant or anything. So, what I said is, it is the initialization list has happened up to this point, the body has started, body ends here. Within that I have taken the C number parameter of the constructor, found out the length, incremented it by 1 for the null character. I have allocated dynamically a character array of that size, and then once the allocation is done, I have done a string copy. Okay. Now, here the point to note is, once I have made it a constant pointer pointing to a constant object, the first thing I cannot do is make this assignment, because the card member will be initialized with nothing, that is garbage, in the initialization. Once I have entered the constructor body, remind you in terms of the object lifetime has started. So, now I have an object. So, card member is now an object, but card member is now a data member of an object, which data member must be constant, because the object lifetime has started. So, if I had to do anything with this pointer, I had to do it in the initialization list, I cannot do it here. So, this will have an error, because I am assigning to a constant pointer. In the other also, when I am doing an strcpy, this is quite obvious, because I am trying to copy and change the string that is pointed to by the card number by trying to make a copy, which obviously is not allowed. So, both of these will fail. So, we have a very nice design in terms of the data member of the card number, having protected it for making it non-replaceable and non-editable, but I am not able to construct the object. So, what I will have to do is, you must have understood that by now, is I will have to use all this in the initialization list itself, because once I am here, no changes can be made, the object lifetime has started. Right? So, let us see how to do this final correction. So, I say that card number issue resolved. So, this is what we have. Now, what I do, I have put a single line initialization for the card number. Just see how I am doing it, because you will often need to do this thing, particularly for constant string to constant data. I have taken found out the length, how much of a big size array we need. I allocate that and use that as a destination for strcpy, and the source is C number. The beauty of strcpy is it returns the copied string, same pointer, right. So, whatever has been allocated here will be first used to copy C number into that, and that same value will be returned by strcpy and get initialized in the card number. So, this is a very typical code. I mean, you might just want to try it out with different types and get convinced, but this is a very nice way of making sure that if I have a constant pointer to a constant string or constant object, then how we can initialize it and get started. So, once I have that, naturally the body has of the constructor has no further code other than just printing the object, just to make sure that we get to see what is happening, right. So, this is my card number, completely unchangeable. This is my holder name, which cannot be edited. I am ready with the kind of design I wanted for my credit card class, and all data are initialized in the initializer list, and that is preferably should be done unless there is a very compelling reason to put some initialization code in the constructor body. Right. If you design it well, it will not be there. Before we conclude, I would like to just remind you of another feature. What you have seen is constantness all over. The whole object can be constant, and for that, to deal with it, I may have constant or non-constant member functions. Data members can be constant, but what is this constantness that means? A constant data member means that it cannot be changed even in a non-constant object. Right. So, either the whole object is constant or a data member is always constant, but if I want to say that, well, I want to change a particular data member even in a constant object, how do I do that? So, that is where the whole concept of mutability, I mean mutable, you understand, something which you can change. So, the constantness as we have treated so far is again called the bitwise constantness, that any data member is constant means you cannot change any bit in. Remember, I mean whole object is const, you can't change anything in the state, but that bitwise syntactic constantness is not always enough. I may want a logical or semantic constantness, which is what is provided by mutable. So, I can say a data member is mutable, so that even when you consider the whole object constant bitwise, that particular data member I would be able to change. Right? That is a specific semantic context in which it comes in, and it is applicable only to data members. There is nothing like a mutable variable. Reference data members cannot be mutable. Static data members we have not discussed yet, when we will come to it cannot be mutable. Constant data members obviously cannot be mutable. Right? So, if a data member is declared mutable, then it is legal to assign a value to it from a constant member function, which is not possible for other cases. So, here I have a mutable, I have a normal member and a mutable member. A constant member function to read, that is fine, you understand. But what I have is a constant member function to set, and I can set the mutable, this member here. I will not be able to set mem here, because it is not mutable. So, once the function is constant, once the object is constant, it cannot be changed, but this one particularly, just this part can be changed. Right. So, if I define a constant object, I can invoke get mem on that, because it is const. I cannot invoke set mem, because it is not a constant member function, this we have already seen. I will be able to invoke get mutable mem, because it is const. I will also be able to invoke set mutable mem, because it is const, though it actually changes the value of the variable. Right. So, this is a very fine grained contextual control on the constness that is provided. So, const in general in C++ is bitwise constant. So, once the object is declared as constant, no part, no bit can be changed, but to support constness which is logical, which often programmers need, the mutable feature is provided. So, to use mutable, we will look for a logically constant concept, and data members, need for data members outside the representation of the concept, but needed for computation. Quick examples. So, I will just show you positive as well as negative example. So, this is when to use mutable data members. For example, here I am showing that I have a math object which has a function pi. So, on the math object I call pi, I will get the value of pi. So, to compute the pi, I have provided an algorithm. This algorithm is terribly slow and all that, but that does not really matter. What I do is I cache this value of pi. So, I have a cacheable boolean. So, what it does, the first time at construction it is put false. So, the first time I call pi, it is false. So, it does this slow algorithm, but then the value of pi will not change. So, whatever value of pi has finally been computed after this long process, it will be remembered in pi, and I say that the cache is true. So, from the next time it will just look up that value. So, it will return pi. Right. So, that is a typical design. Right. Now, in my use, I have a obviously math object has to be constant, because the value of pi and so on cannot change, and I am invoking this, which is a constant member function. It has to be, because otherwise on constant object I cannot. But I needed to change the both these. I needed to change the value of pi in the context of doing it first time, which is a computational requirement. Logically pi is constant, but the first time I am doing, the pi is not there. So, I have to be able to compute and put it. So, that is the reason I am putting this mutable, and to support that pi cached is also mutable. So, even in a constant object, the variable, the data member is made mutable, so that I could compute it on demand, and henceforth whenever I want I will use it. Naturally, these are somewhat advanced risky design concepts. So, you have to use them properly. The second I show is when not to use mutable. No. Suppose you have an employee class and you say that mutable double salary, that because the name cannot be changed, the ID cannot be changed. So, it is fine, you say that okay, I will make the entire employee object constant and allow the salary to be changed, because salary can change. So, I have get name, get ID, get salary, all this as constant member function. I have promotion as constant member function, and so on, and it changes the salary, which is allowed because it is mutable. This is a bad design. Programmatically, yeah, you will get through, but this is not the design for which you should use mutable, because conceptually employee is not a constant. Conceptually an employee object is not a constant, only its employee's name and ID are constant. but otherwise it is an evolving object. So, this is not a preferred design. What you should do is rather make name and ID constant, and there is no need to make it mutable, because you should not be treating employee objects as constant. You just make sure that name and ID cannot be changed. So, get name will still have to be a constant, get ID will still have to be constant, set name and set ID must not be there, because you will not be able to change them, they are a constant. Get salary will be a constant, and promotion would be there as a normal member function. Right. So, please understand this difference, that it is not that you can just use mutable with constant make something work. You have to ask yourself conceptually, is this object constant? So, conceptually whatever is constant you go by that, then rest of it you handle either by constantness of data members or by mutability of data members, and you support your design through the constant member functions. This is in jest what your design of constantness should be doing. So, we have talked at length about the varied kinds of constantness and mutability. Thank you very much for your attention, and we will meet in the next module next week.